calling, you calling, 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 calling. Calling, calling, you calling, 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 calling.
Hi, good morning. I'm Becky Hall. I'm the Executive Director here at the Nevada Science Center.
I'm Dr. Josh Bondy, and I'm the Director of Research here.
So we're located down in downtown Henderson, Nevada. So if you're local here in the Las Vegas Valley, we're in the southern part of the valley. Otherwise, we're in the south corner of Nevada for those who are not here. So one state over from California in the southwest of America.
All right, and so today we're going to be talking about geology. And so Nevada is one of those states that it's the most arid state. So it's the driest state in the United States. In a previous talk, we figured out we only have about 4 to 5 inches of rain a year, depending on where you're at in the state. But because there's so little precipitation, there's so little rain and snow, there's not very many plants that cover our rocks. And so Nevada is really rich in rock resources. And so that's why we're going to talk about geology. So geology is the study of the earth. As the name implies, so geo is the root earth, and ology is the study of. And so there's lots of different types of geologists. So geologists study, like me and Becky, we're paleontologists, so we study ancient life. We're also sedimentologists, so we study how sediment is dispersed across the planet, what that means for ancient ecosystems, and make interpretations that way. There are geologists who study faults. So if you live in an area that has earthquakes, there's geologists that study just those. There's geologists that study how mountains are built, how old rocks are, how old artifacts are. So geology is a great big field that covers a lot of different subdisciplines.
And not just on Earth, there's geologists that study rocks from the moon, from Mars. So our whole universe is made up of rocks.
Exactly. So if there's a rock, there's a geologist that wants to go hit it with a rock hammer. So one of our basic tools is a rock hammer. So you get to go hike around the hills and you get to bang on rocks with a hammer. If you're in a place that you're allowed to do that. Don't just go hit a rock in somebody's front yard. You might get in trouble for that. So the study of geology is actually the basic unit of study is rocks, as I just said, or a rock hammer, or a dembe, as my tribe calls them. So rocks are the basic study of the earth. And so some people get confused with the difference between a rock and a mineral. So minerals are specific features that have a crystalline structure. So like glasses don't have a crystalline structure, so they're not technically minerals. It has to be inorganic. So even though sugar kind of looks like a crystal, kind of looks like a mineral, it's an organic compound, so it's not technically a mineral. And it has to have a regular chemical structure. So minerals are these little building blocks that make up rocks. And so rocks, I'll just pick up a random rock, can be made up of all sorts of different types of minerals. It can be made up of shells or pieces of plants. So rocks are just kind of pieces of minerals or minerals all glued together to make basic types of rocks. And so with that, I'm going to hand it over to Becky, and she's going to talk a little bit more about rocks.
Okay, let's switch spots. So like Josh was saying, rocks are made up of a whole bunch of different things. So we have 3 different types of rocks, and we're going to be talking about the rock cycle. So where do these 3 types of rocks come from, and why do we have them, right? So the rock cycle is just that, a cycle of rocks. So rocks get recycled into our earth and become different rocks. So we'll first start with, how about a volcanic eruption, right? So on the news or you've been watching lately, there's been a lot of volcanic activity around the earth. So we have lava flows, we have different types of volcanoes that erupt differently. But anyway, so first we have lava, right? Coming out, and as it cools, it becomes an igneous rock. So volcanic rocks are called igneous rocks. So I have a few different examples. If you want to come in closer, we can talk about igneous rocks first. So this is a piece of basalt. So this is kind of like what would come out and cool. This dark, it has little holes in it, so it's the little air bubbles popping. So this is basalt. This is an igneous rock. Here's a couple other ones. So as igneous rocks cool, they can either cool very fast. So like basalt, it came out really fast out of the earth and cools. That's why we have some like air bubbles, but sometimes igneous rocks come out of the earth very, very slow and kind of just rise up from the surface. And when they come up to the surface and cool a lot slower than a hot exploding lava, you have mineral growth. So we also have like granites. A granite is a type of igneous rock. But if you come in closer, like Josh was saying, rocks are made up of other minerals, right? So here you can't really see that mineral growth. But here you have some oranges in there. So the different colors, some clears, some whites. So you have some feldspar, which is a mineral, some quartz. So a lot of these you'll find on your like countertops. Of granite is often used for countertops or tiles. So it's kind of fun looking at those features when you're even just sitting down at the kitchen counter. All right, then we have some type of rocks. I don't know if this one is that kind of cool, a little bit slow, fast and slow. So you have some mineral growth and then a lot of where you can't see it. So this is another type of igneous rock. This one's kind of cool. It's pretty, right? But these are actually the deepest rocks that we have here on Earth. So this this green, I'm sorry, is called olivine, right? Olive's kind of easy to remember if you ever had a green olive. But this is part of the mantle. So the mantle is the innermost part of the Earth, and it rips up from the mantle as it's coming up, exploding. So we have some minerals on this basalt here, which is kind of cool. And then we have an all-time favorite that people love to look at. So geodes, right? So what is a geode? So a geode is like a little air pocket in igneous rock. So here's one that's closed, not broken open. And then when you crack them open, you can find, so this was like minerals that grew in the pocket of this igneous rock. So you can see some of the crystals in there. So these are kind of fun. We have these in our science center. People can come and crack them open. All right, moving on. All right, those are igneous rocks. We'll move a little bit faster. So then we have sedimentary rocks. But how does it go from this type of rock, let's say this type of rock, right? So it takes a long time of weathering. So mountains get rained on, snowed on, earthquakes, landslides, and you have big pieces of rock that go into very tiny pieces of rock. So we have sandstone here, so made up of quartz, little pieces that have traveled very far from mountains to become sandstone. So this is all sediment that's turned into sedimentary rock. And then we also have limestone, so sediment from the ocean that settles at the bottom and creates limestone, which is another type of sedimentary rock. So in limestone, we can find fossils. So in here, we have some little bit of corals in there. I don't know if you can see those.
A little bit, yeah.
Yeah, a little bit. And then we have trilobites. So that's a shale, so really, really fine type of marine sediment.
Mud.
And then as we're going through the rock cycle, so we have our volcanic eruption, igneous rocks, weathered out to sediment, so little pieces of rock, turn into sedimentary rock. And as that sediment gets packed and pushed down deeper and deeper and deeper in the earth, there's lots of heat. You know, the middle of our earth is very warm, lots of pressure, all that pressure. And then they turn into metamorphic rocks. So here, it's a piece of schist, but it's different than the igneous rocks because you can actually see lines in it. So it's called foliation. We have mineral growth in there. So those are some garnets. So you
The
can
little red blobs in there.
yeah, the little brown red ones right here are called garnets. So this is another with lots of heat, pressure, and time in the earth turns into a metamorphic rock. So a metamorphic rock also has a parent rock. So it doesn't just become a metamorphic rock. It has to have a parent rock, like a sandstone or a garnet or granite. So that's a metamorphic rock. And then the deeper and deeper and deeper it gets, it turns back into magma, so liquid rock, right? So it's no longer can be a rock, turns back into magma, and it can start this cycle all over again. So I have my little corner of minerals here. So minerals have different properties, and that's how we can identify the different minerals. So it's fun to identify rocks, right? What kind of rock you have, or you have a igneous, sedimentary, or metamorphic rock. Those have characteristics, and so do minerals. So from the color, so we have some rose quartz right there, so pink, right? It's an amethyst, so purple. So
Also quartz.
also quartz. We have let's see, what's another color? Green, so like the olivine, but this isn't olivine because it has different properties to it. This is calcite too. So the color can be a property. Another property, how about a fun property? How about some rocks are actually magnetic? So this is magnetite, it's polished, but you see, it's even hard to pull them apart. See how they jump? Watch. So they pull together, they're actually magnetic rocks. The luster, so how does it look? Does it have a shine to it? So we have metallic luster. So here's a piece of pyrite.
Luster is how the light reflects off.
Yeah, so you can see it's kind of shiny, right? Both these. So we got metallic luster, glassy luster. So here's a piece of gypsum, selenite. Earthy, right? Doesn't have really much of a shine to it. So that's another property. And then hardness, right? Should we go into hardness? So all minerals have a different type of hardness. So some are very hard. So you've heard like a diamond, it's like the hardest mineral, so it can cut glass. So we also have minerals that can that look very similar. So here we have two different minerals, and I'll tell you what, but they look very, very similar. So how do we tell them apart if they kind of, they look very similar? Another way is doing a hardness test, and you can just do it really easily with just even your fingernail. So we have different things to test hardness. So some minerals can be scratched with your fingernail. Another one could be a penny or even a nail, right? So here we have two minerals. And this one, here, maybe go over here. I can scratch with my finger. You see that powder come up? So that's a pretty soft mineral. Or this one, it's very hard. I can't scratch. Oh, there, the nail did it, but not the penny. So the difference is they have different hardness. So this is gypsum or selenite, and this is calcite. But calcite also does a really cool thing. So another property is if it fizzes with acid. So here's just some house vinegar. We'll see if you guys, maybe I can scratch up some of this with this nail, get some powder going. It fizzes with acid. That's a characteristic of calcite. Oh, there it goes.
Fizzing away. That won't happen with the gypsum.
No, it would not happen. So different properties again. So that's how you can identify some different rocks.
What about how they break?
Oh, so we have either cleavage, so the way that a mineral breaks in a smooth plane, like so the gypsum, you can see it breaks nice and smoothly. We have flaky, so this is muscovite. So it actually comes in layers like that. So it's platy. You see how it breaks apart like that in layers. And then we have, a fracture. So here's a good quartz. So it doesn't break nice and smooth, the calcite. It has kind of a rigid break to it. It doesn't break very nice. It doesn't have a nice plane to break. So that's another characteristic of minerals. Thank you, Josh.
Mm-hmm.
All right, so then we'll talk about a little bit. So Nevada, like Josh said, there's lots of geology here. You can see the rocks, but geology is very also important for Nevada's economy. So Nevada has lots of mine and lots of minerals that we use in our everyday lives.
Yeah, so as I mentioned at the outgo, that Nevada has lots of geology resources, lots of rock resources. Again, the rocks are easy to see because there's not so many plants. So outside of the southern Nevada area, across all of northern and central Nevada, mining is one of the largest industries in our state. And so the motto of the mining industry is if you can't grow it in a farm, it has to be mined. And so the way that we enjoy our quality of lives all comes from materials that we mine out of the ground. So the computers that you're looking at right now, or the smartphones you're looking at right now, all incorporate all sorts of earth materials that had to been extracted from the earth, processed, refined, and then built into, either what we're wearing, what we're using, your watches, your jewelry, and again, your technology. So some mineral resources since that's the most obvious use of geology or geological knowledge is how do we get stuff that we need out of the earth? So we have some pretty unassuming rocks here in front of me that can actually help our everyday lives. So here, we'll start with this one. All of this bluish gray mineral growth here is from Esmeralda County. And this is the type of rock that silver comes from. So if you have silver jewelry on, or if you're using any sort of technology that utilizes silver, this is what the raw material looks like. It doesn't have that nice silvery, metallic luster to it. It starts out like this. It starts out as a rock. It starts out as a mineral. And so geologists have to go out there and find this, and then chemists have to process it, and all the miners have to extract it from the ground in order to process it into the material that we use for industry and for jewelry today. So that's silver. Nevada's nickname is actually the silver state because of all the silver that was originally mined here. But Nevada is actually one of the largest gold producers in the world. And so this is one of these gold ores. So in this rock, it just kind of looks like banged up quartz. There's some other minerals that are kind of going through here as well. But if you were to process this, grind it down, and you do the right chemistry, this rock is actually worth money because of the gold that's in it. And so ore, I've used that term a couple times now. What is an ore versus a rock? Ore simply means a rock that's worth money. And so if there's something in a rock that makes it valuable, that makes it an ore. These two are copper ore. And so you can see that really, these are some me and Becky's favorite minerals. So the blue is azurite and the green is malachite. These are copper minerals. So they're really pretty, but they're also considered copper ores. And then here we have some more malachite and chrysocolla. These are also copper minerals. And so these are mined in order to get copper wiring, any other aspects that we use in our world for copper. Iron, these two minerals that Becky was just holding up. So we have hematite and pyrite. These are both iron-bearing minerals. And so these are both ores that we mine and process in order to get iron that we need for everyday life as well. Construction, automobiles, aspects like that. Some other uses of rocks. We have industrial minerals. So this is diatomite or diatomaceous earth. It's made out of microscopic pieces of ancient shells that are used in abrasives. They're used also in filters. Like if you're drinking soda pop, your soda was probably filtered through a rock that looks like this. And because me and Becky are paleontologists, we also like, there's fossils of them too. So rocks can also tell us about ancient life, since rocks preserve all the fossils and all the stuff that records our record or our history of life on Earth. Rocks can also preserve really dramatic events in Earth's history. So see all of this broken up rock? This is all limestone. It's part of an ancient reef that was here in Nevada outside of the town of Alamo in Lincoln County that got smashed by a meteor about 370 million years ago. So this meteor smashed the big coral reef. It smashed it all into this breccia. So this is a meteor impact breccia. But we wouldn't know that would have happened if it wasn't for studying the rocks. And in studying rocks, we can also figure out ancient mountain building events. We can figure out where sediment flowed and came and went, where dinosaurs walked and why they became preserved, and the types of environments in which they lived. And it also preserves pretty things. So this is a piece of Nevada turquoise from Lander County, also preserved in rock. So this is one of Nevada's semi-precious minerals, or semi-precious gemstones, is turquoise. So if you enjoy turquoise jewelry, that you couldn't get that if it wasn't for the study of geology. All right, so with that, we got a fun activity that I think Becky wants to share with all of you today. So I'll follow her over there. Quick walk through the Science Center.
Ready? So we have a new fun activity here at the Nevada Science Center. So if you're local, head on down and we want to show you our mining sleuth. If you're not local, what I want to show you is some of the things that we learned today. So what kind of rocks we have, ways to identify minerals, and when you're either hiking, finding your own rocks and minerals, or come down to the Science Center, you can identify your own minerals. So here we have our own fun mining sleuth. You can come down and get a bag. So I'm gonna we have some bag with minerals and sand in there. I'm gonna clean it off real quick. So some of the minerals in this bag, we can use some of the stuff we saw earlier and we can identify. So here right off the bat, it caught my eye, right? So looking at the properties again.
That should be familiar.
Yep, it should be from fool's gold or pyrite. So we have a shiny, how do I know that? What, a shiny luster? The color, right? Metallic color. We have other things in here. So green. I know I didn't tell you all about the minerals, but this is like fluorite we saw earlier. We have some quartz, because that doesn't have the nice cleavage, smooth cleavage. It kind of fractures. Remember we talked about that. So that's how another way. So you can use what we learned today to identify the rocks in your hiking. Or if you do find a mineral, try to identify a mineral that you find out in your hiking. So you can always read more. You can get like a little pocket mineral guide if you'd like to put that in your hiking bag. So with that, we'll shoot it back for questions. So I'll just do it over here.
Absolutely. And again, guys, keep those questions coming in the chat. I know we had some people email me questions, so we'll just jump right in. We have a question from Brianna, who is here in Nevada, and she wanted to know, why are rocks hard? More specifically, I'll elaborate on that. Why is there different levels of hardness for each of the different rocks?
So the different types of hardnesses in rocks and minerals has to do with how the chemical bonds hold the individual atoms of those individual minerals together. So the reason that diamond is so strong is that it's only made out of carbon atoms. And so all those little carbons are what's called covalently bonded. And so that means they share their electrons. They're super intertightly locked. Whereas some minerals, like Becky was showing us, that muscovite, she was able to just peel apart. Those are like pretty much held together by static electricity. And so they're really soft.
One of those, sorry. Go ahead, Becky, sorry.
I'm saying, so it's chemistry too. So geology is the study of a lot of things. So, you have to understand physics to understand Earth's processes, and chemistry, because every mineral has a chemical formula. So it's really about understanding all different types of science that go into geology.
Absolutely. We have a question from one of our students here on the East Coast here in America, and they would like to know, you guys are paleontologists. Do you guys ever come across rare metals or minerals in your findings?
Yes, just last weekend we were out we were looking out for fossils, and I came across a gemstone, and I haven't identified it yet. We're thinking maybe it's a sunstone, but yes, so we do come across other findings. A lot of our rocks that we showed you today are things that we stumbled across. I found some really cool things in Death Valley. So that's another thing about when we're out looking for fossils, that we do have our eye on the ground, and then we do stumble across some other treasures.
That's exciting stuff. We have a question from Asia, and she is in Italy. Asia, you should be able to unmute to ask your question.
Yes, hi. I was wondering, what is the thing that you like the most about your profession?
I would say the thing that I like most about our profession is that we get to get outdoors, we get to go hike and explore, and whether it's geology or whether it's paleontology, it's that whole act of discovery, it's that whole act of being out there and being involved in like the elements and everything else like that. So that's my favorite part.
And just like Josh was saying earlier, is like how we are paleontologists, but our background is also being geologists in geology, getting degrees in geology, is understanding the bigger picture. So when we do come across a fossil, it's just like, for all the processes that happen and like what's happened in the 120 million years since we found this dinosaur that laid here, it's the amount of the geologic time one is a really deep concept. And then just thinking, the Earth's history and just the bigger picture at large, I really, really enjoy putting those pieces together.
It sounds like that you guys have to learn a bunch of different disciplines between across different subjects within science, as well as world Earth history. So one of the students wanted to know, what can you recommend that they study if they want to go into geology as a profession?
If you want to study geology, go get yourself, like Becky was talking about, one of those little rock identification books. There's rocks in everybody's backyard. There's rocks on your way to school. There's rocks on your way to work. Just check them out. The more you look at them, the more you get interested in them. I once had a mentor tell me the geologist who wins at the end of the day is the geologist who's seen the most types of rocks.
Right, we get out a lot, and I will agree with that. So you can start just by going out and exploring, just like with fossils. Just go out and try to find a new, we're still finding rocks that we're trying to identify, sending pictures to friends, because, you know, like, what is this? Look what we found. So rocks are exciting. You know, everyone has seen a rock or has a little rock collection. And geology is, yeah, since there are so many disciplines, you can really do a lot of things that, you know, whatever sparks your interest.
That is awesome. And before we let you go, can you guys tell us a little bit, those of us who are new to this, a little bit about the Nevada Science Center, and before we let you go?
Right, so you can check us out down here in downtown Henderson, otherwise on our website, so sciencecenternevada.org. I'm sure Ralph will include that. So we have upcoming events, some more virtual events. We now have our doors open from the pandemic, so you can come in and check out our, not just our little rock shop, but we also have fossil displays, and it's our research lab. So we are active scientists, active researchers that work on fossils from across the state. Is there anything else you want to add?
We're on all the social media platforms, so you can check out YouTube and all the other major platforms, see what we're up to.